In this example, I'm going to show you how to evaluate determinant A by expanding across the first row. And this method works no matter where we want to expand. When we can expand the second row or third row or first column if we want. But for this particular example, we want to expand across the first row instead. So here is our first row. So the entry here is first row, first column. So here entry first row, first column times the factor of that. Then this is a first row, second column times a cofactor, and then we add the entry of first row and third column and multiply its factor, cofactor. And the cofactor pretty much is help us to determine the sign of the minor. So here is the cofactor of row 1, column 1 will be a -1 to the power of 1 plus 1, which is 2. 1 plus 1, it comes from where we at. We at first row, first column. Then times the minor. And the same thing when here have a row, a cofactor of row 1, column 2, we go to -1 to 1 plus 2. It's because we add row 1, column 2, and time its minor. And then the same thing for the last one. We have the cofactor of first row, third column. So therefore I have -1 to the 1 plus 3 times its minor. So you see that for this guy here, because I raise to the second power, -1 to the second power is a positive 1. So I have a positive 1 times the minor. The last one, this one here, I actually had a minus here because 1 plus 2 is 3. So -1 to the third power is should be -1, just a minus times m12 be minus minor. And the last one is a positive 1 because 1 plus 3 is 4. So -1 to the 4 power is positive 1 times the minor 1, 3. So the determinant A can rewrite as this, as a minor here. Now this guy here was a positive, become a 90 minus because of this right here, because of our cofactor, and the sign become minus. So this is what I'm going to use right here to find the determinant of A. And here is I'm going to find the minor of first row, first column, meaning you delete first row, first column. So we delete first row, first column, and then you keep the whatever left over, which is this piece right here. Now I'm looking for determinant of 2 by 2 matrix. This is 2 by 2 matrix, and to do that I take 3 times 4 is 12 minus 1 times 5 equal to 7. And to find the minor of first row, second column, here's our first row, second column. So we just keep whatever left over. We have -2, and then -2, 1, 4. Now we evaluate 2 by 2 determinant, which is -2 times 4 is -8, -1 times -2 is -6. I'm doing the answer. I'm tend to put the answer. I did the answer ahead of my head. So it's 2. So it's -6. Sometimes I tend to Okay, no answer. I had to actually evaluate the answer so quickly that I say things wrong or word out wrong. The last one means I'm deleting this first row of this column. And whatever left over, we copy it out. So I have -2, 3, 5. And the determinant of this would be -10 because -2 times 5. Then take the product of 3 times -2 is -6. So I have -4. Okay, yes, this will become a plus. So now I apply. I just copy the determinant of A down again, and now we can find determinant of A. This here, the entry of 1, first row, first column, it's right here. So which is 4. This is mean the entry of first row, first column right here. This is the guy, it's 4. Time the minor of that will be 7 minus the entry of first row, second column is right here. So therefore I have 2 times this was -6 plus this guy will be -1 times -4 so I have 28 plus 12 and then plus 4 which is equal to 44. This is our answer. Now next I will show you to evaluate determinant by using Sar's rule. This is a shortcut, and this method here help us to evaluate determinant A faster, and is very efficient. And this method, we don't care what expansion we want to do, column or row, doesn't really matter. And let me show you how to do it. The first thing, we have to write the first 2 columns of matrix A. So the first 2 columns of matrix A will be 4, -2, -2, 2, 3, 5. Then to the right, I'm sorry, we had to write the first, we had to write the first 2 columns of A to the right of A, so that was 2 columns here. It can be. Then we're going to multiply the entries along 6 diagonal. I'm going to show you, I have 6 diagonal. Here the first diagonal. Okay. When I'm going from the left to right, this way, it's plus, the sign will be plus. Then I have another diagonal, should be from here down this way, that way, and that way. Now, the only thing about this method is you have to be careful when you're writing down. Make sure you sloppy, and then your diagonal can be like a cookie, and it won't be nice. Then it's easy to make a mistake. So the way it's important to be neat with your work. When you go diagonal this way, the sign will be minus. Okay. So now we're going to take the product of all our diagonal here. Okay, so we have 4 times 3 times 4 plus the plus here, and then we have, so the diagonal here will be 2 times 1 times minus 2 plus this, the product of this guy will be minus 1, minus 2, and 5. Now do this at diagonal here, because I'm going this way, so there's therefore I have minus there. So I have a minus 1 times 3 times minus 2, then minus the product of this guy will be 4 times 1 times 5 plus 1 will be this one, will be 2 times minus 2 and 4. So I have 12 times 4 is 28. This is minus 4. This is plus 10. This whole thing here is a positive, because the minus is 6, minus 20, and then this is a positive, because I have 2 minus sign here, it will be 16. I see that this is minus 6 is minus 10, plus 10 will be 0. Excuse me, this will be 48. I mean 48. Because 12 times 4 is 48. What else we have? Think it looks good. So now we have minus 20 plus 16, and then you plus 48. That becomes 44. Because minus 20 plus 16 is minus 4, then plus 48 is 44. You see the answer here? Look exactly the same, the answer I got early. Right here, exactly the same. I like this method, this rule better. It's faster. It's awesome.